Hello curious mind, welcome to Space Lab.
In this episode, we'll learn how to use a photoresistor and turn on the light when it gets dark. We'll also see how our Arduino can understand analog signals and how we can use serial monitor to read them.
For this, we would need a breadboard, the microcontroller, an LED of your choice, the photoresistor, two 1 kilo ohm resistors, and 6 connecting wires. Let's see how the connections are made. Connect your LED to 5E and 6E. Connect the photoresistor to 20E and 21E on your breadboard. Connect one of the resistors to 1D and 5D. Connect the red wire, which is the powering line for the LED, from the port 7 on your microcontroller to 6A on your breadboard. Connect a blue connecting wire from 1A to the negative on your breadboard. Connect a black wire from the ground to the negative on the breadboard. Connect one of the red wires, which is powering your photoresistors, from 5 volt on your microcontroller to 21A on the breadboard. Connect microcontroller to 20A on the breadboard. Connect another resistor from 16B to 20B on your breadboard. Connect a blue wire from 16A to the negative on the breadboard. A photoresistor is a special type of an LED or a resistor which changes its resistance based on the light it detects. Once it detects a change in the light, it sends the signal to your microcontroller, and based on that, your microcontroller generates a signal for the LED to either light up or shut down. Let's see how the programming is made.
Our microcontroller can measure analog signals in form of voltage and transform them into values for us. And to do so, it uses 10-bit, which means there are 1024 different values from 0 to 1023. When the voltage is 0, then the microcontroller will measure it as 0. And when the voltage is 5 volt, which is the highest, the microcontroller will measure it as 1023. To be able to use this feature, we will need to use the analog port on our Arduino. That's why we define a variable analog port and set it to A0, which is one of the analog ports on our microcontroller. Let's also set the starter value of our signal with the variable sensor value equals 0. We also need a variable to define our LED pin. Let's take pin number 7. Now let's get down to setup. This time we're going to use serial monitor to listen to what Arduino wants to tell us. This way we'll find out the value that will tell us when it gets dark enough to turn on the light. Are you wondering how? Well, we will ask Arduino to convert the voltage into a number for us and print it in the serial monitor. So when it's as dark as we want, we can see the value and use it later. First, we need to open our serial port to start communication with Arduino. Do this with serial begin 9600. As usually, we also need to set our LED to output with pin mode LED output. Now, finally, let's write the loop. First, let's make Arduino read the value from the photoresistor with sensor value equals analog read analog port. Now we want to see the value on serial monitor. For this, let's first print the word analog value and then let's print the value itself. Pay attention, we use print when we are showing just a phrase or a word in brackets, which is called a string. And we use print ln if we want to show the value that Arduino calculated for us. Now let's run the program and see what Arduino prints for us. Here we can see the values that we get when it's light. And now we can see the value that we get when we cover our sensor. It's between 700 and 900. Now that we have a value, let's use it to turn the LED on or off. We continue writing our program with an if statement. If the sensor value is less than 900, we turn the LED on. Otherwise, we turn it off. And then we keep it on or off for some time with delay 5000. We set it to 5 seconds here to show you how the LED turns off when we cover it. The shorter the delay, the quicker your LED will react to changes in ambient light. Now the sketch is complete. Let's run it. It's morning and it's light. The LED is off. Now it gets dark. Voila! The LED is on. Do you have any cool ideas how we can use it? Share them with us in the comments. Give us a thumbs up if you liked this video and subscribe for updates. See you next week!